yet to come. But at least we'll both be beautiful and stay forever young. This I know, this I know. She told me don't worry about it.
Hello, we're students from Repate Boyal, and in this video we're going to teach you about exponential growth and decay functions, and related with environmental issues like the Chernobyl explosion in 1986.
Hello students, in this class I'm going to teach you what is exponential growth and decay.
Teacher, but what is exponential growth?
Exponential growth is a mathematical change. The rate change continues to increase as time passes. This is the function and the graphs look like this.
And what about exponential decay?
Exponential decay is also a mathematical change. The only difference is that it decreases as time passes. This is its function and the graph look like this.
Another important piece of information about these functions is that their domain in mathematical means is this, from negative infinity to positive infinity. The range starts in a point x, doesn't touch that point, and goes until infinity, or can go from negative infinity to such point. The graph, as we said earlier, will look like this. Its normal reference point is this, 0,1, and as we can see, the domain goes from negative infinity to positive infinity. But obviously, in real life situations, it must start somewhere, in this point or maybe in 0. But what we can learn about these functions is that this is their mathematical normal way.
Teacher, and what are the implications of using nuclear energy?
Nuclear energy is considered clean energy because it doesn't generate CO2 emissions. The wastes of nuclear energy may remain thousands of years. The wastes are from iodine, strontium, and calcium, and they may lead to DNA changes in humans, animals, and plants.
Teacher, do we in Mexico have nuclear plants?
Yes, it is located in Alto Lucero de Gutiérrez Barrios, Veracruz, and it's named La Central Nuclear Laguna Verde del Gobierno Federal de México, and it's under the control of the Comisión Federal de Electricidad.
But teacher, is it safe?
Since the regulations and security of the plants are approved by the CNSNS and the Ministry of Energy, I think it's safe. And if they take the needed preventions and are far from protected natural areas and populated zones, we agree with it.
Teacher, could the Chernobyl disaster have been prevented? How?
Yes, by using a moderator of temperature in the tips of the control rods and well-prepared people in the nuclear plants because they have an electrical engineer without a reactor training performing the test with the reactors.
Teacher, what about the pollution? Did it affect Mexico?
No, because Chernobyl disaster occurred in Ukraine, a country that is 6,710 miles away from Mexico.
What are the global environmental consequences of this kind of nuclear explosions?
There are 4 environmental consequences caused by the Chernobyl 1986 disaster. We have the effect it got to plants, the effect to animals, the effect to fish, and the effect to urban areas. For plants, the effect was that the plantations were affected by the accident directly because they got burned, but afterwards the land and the plants on the farm was contaminated with radionuclides, which made it impossible for plants to live. By the other hand, animals were also affected. For example, cows. They started dying directly because of radiation or the explosion, or the other thing was that they were being born with mutations which wouldn't let them live or produce milk. In the case of fish, the water got polluted with elements like iodine, cesium, and strontium. This caused the fish to die and also made it dangerous for human consumption. It decreased the quantity of fish in lakes and ponds and affected the whole ecology. The most affected areas had to be evacuated quickly. Most of the green areas in the cities were dried and rain transported radioactive materials. The radiation induced cell death and deformations or mutations in the population. The heat waves released in explosions caused massive fires. Short-term sickness include vomiting, diarrhea, and intestinal malfunctions leading to dehydration and malnutrition. Strontium and cesium emissions cause thyroid cancer. Strontium also causes bone cancer and damages in the bone marrow. Radioactive emissions also have consequences in the DNA that can be passed through generations, leading to malformation of newborns in the mothers that were exposed to radiation.
Okay guys, now I'm going to show you a YouTube video of two experts on the topic.
Hello. Welcome. Tonight in the show we have Dr. Cruz, who is going to talk to us about the sad events that happened in Chernobyl.
Thanks for having me here.
Thank you.
The Chernobyl power station exploded, making it the world's first and worst nuclear accident. The power level was lower than it normally was, in a level where it shouldn't be, below the safety minimum. Still, the deputy chief engineer ignored these level changes. The regulation stated that the power level during test should be between 700 and 1000 megawatts, and still the chief wanted to start the test when the power level was only in 200. 1 kilogram of uranium can produce the same amount of energy as 3 million kilograms of coal. Now, below the 50-foot reactor, there are 1,661 uranium-filled fuel rods, which are this type of little tubes, and they are together and connected into the reactor's core. The splitting of the uranium atoms causes a release of great heat from the rods and turns the water into steam, and this steam causes the movement of giant turbine and generates electricity. And in order to control this amount of electricity or power, the reactor uses boron rods, and if these rods aren't present, workers lose their ability to control the power and to use this type of brakes. And this precisely was what the problem was all about, because the chief wanted to do the test that night. After the lowering levels of power reaching zero, they managed to increase it once again. The power level reached to 200 megawatts, and the chief requested for the test to begin. Even when the workers didn't want to begin because the regulation said that tests can only begin if they are 700 megawatts. Throughout the night, many alarms were setting off due to the water shortage issue in the regulator, but no one thought it would be a big problem at first. They have already estimated the possibilities of an accident in Chernobyl, as in 1 in 10 million. Now, power is building into a hot spot at the bottom of the core, where the sensors won't always detect. So this means that the reactor is now an invisible ticking bomb. Then, at 1:23 a.m., the test started and the two turbines from the reactor were turned off. So the pumps now push less water through the core. So now, the steam pressure rises every second. A worker that was down next to the reactor witnessed the steam lifting the 350 kilograms of fuel rods and tries to warn the engineers. Power was now rising each second in a drastic way. Thanks to this, the tops were lifting from the reactor lid. Suddenly, the steam pressure from the hotspot cannot be contained, and the rods were being torn apart, and the first explosion occurred. Seconds after the first one, the second one also occurred. The second explosion released 50 tons of nuclear fuel into the air, which is 10 times Hiroshima. 700 tons of radioactive graphite were blown into the atmosphere as well. The engineers from the operator room, including the chief, survived the explosion, but were now exposed to radiation. The reactor was now in ruins. Fire services were called after the explosion. Many sectors obviously were on fire. Well, that's all from me. Thank you for having me here. And here's my colleague Patronsky Sluvans.
One day after in the morning, the clouds were very contaminated. Reporter Ariel Costin and his team fled in a helicopter and were the first team to film the scene. They didn't know what happened, so they wanted to get closer to be able to get a better shot. Once they were above Block 4, he opened the window without knowing how much risk he was running. He was one of the few people who survived such exposure to that amount of radiation. Back on those days, the unit of measuring radiation was Roentgen. 2 Roentgens can be absorbed by humans without being harmful per year, but the body is lethally affected if you get to 400 Roentgens. In the same day it happened, the people received 50 times what it is considered to be a harmless dose. If it continued that way, they would get to a lethal dose in 4 days. Near the station, it was 2,800 Roentgens. With that amount of radiation, it only takes 15 minutes to take a lethal dose. After 20 hours after the explosion, the radiation levels continued to increase. By then, to prevent the amount of radiation to get inside the house, they should block all windows and doors with iron tablets, but this was not told by the government. They maintained it in a secret. After 30 hours, the first security measures were made. 1,000 buses came to evacuate everyone. After 3.5 hours, 43,000 people were evacuated. They needed to act fast, but they couldn't start working because the levels of radiation still were very high and kept rising. The government sent soldiers with sand and boric acid, which neutralizes radiation. Some of the pilots made up to 33 flights carrying soldiers, which threw sand with their bare hands. Each time they went, they received a dose of 6 to 7 Roentgens. The ones who later got sick were sent to the hospital. After a week of the explosion, 130,000 people had already evacuated the zone, which many may have been already contaminated. 30 kilometers around the plant was danger zone. The contaminated clouds crossed until France and Italy. The magma under the sand was cracking the cement under it. The fireman who got fast after the explosion threw water under it, and if the magma reached the water, it could cause a bigger explosion than the first one. It didn't happen, but if it had, it would have taken thousands of lives in a matter of hours. The water went away, but the magma still kept going down. Under the plant, there was a river which supplied the entire country with water. To prevent another explosion, they sent miners to dig under the reactor to make a room with a cooling system of liquid nitrogen. After 18 days, the people were finally notified of what had happened. After they controlled the magma situation, they now had to fight the radiation. For this, they sent 100,000 soldiers to liquidate the radioactivity. They went from the house to house, removing the radioactive dust which covered everything. After 8 weeks, that liquidated the heart of the problem. In order to neutralize the radioactivity for good, an engineer was working on something to isolate the whole Block 4. It was an enormous structure which covered it all, made from steel. The design has not been applied yet, so the only solution they could find was to evacuate all the people near the danger zone.
Hello again, folks. Hope you enjoyed our doctors talking about this horrible issue. Hope you learned something. Two more events to conclude that also include this kind of issue related to nuclear explosions and exponential functions are the following. The event that ended World War II was the US bombing Hiroshima and Nagasaki. These nuclear bombs that fall are related to exponential growth because when they touch the ground, they start a chain reaction that splits the atoms, and those atoms split and so on. So the radiation expands and the whole city was destroyed. Sickness like leukemia and mutations were some of the afflictions that the citizens of Hiroshima and Nagasaki suffered that day. Another example of an event that included both radiation and exponential growth is the nuclear accident of Fukushima.
which happened in the nuclear central of Fukushima 1 in Japan. This was caused because of the implications that succeeded the, the earthquake and the tsunami that shook Japan in 2011.
Oh, teacher, ya sonó.
Okay, guys, the class is over. You're dismissed. Have a good day. My solution is that when it comes to radiation, a specialist should take the needed precautions, and I liked it working in teams because it is easier, and I like the most that it was fun.
What do you think? What do we think and feel about these consequences? Well, obviously, we feel really bad about these consequences that kill many people and take away their lives because of the radiation and the moment of the explosion. So, yeah, we feel bad.
I feel really bad that this happened, but this we can take this as an example and prevent other of these nuclear bombs or explosions.
I think that it could happen again. So whenever we have a nuclear plant, we should have the highest security criteria. And I feel that the world has learned something from this kind of incidents.
What would be a solution proposal for this situation?
Well, obviously, it will be very hard to contain a radiation once it is exposed. So, for that conflict, we don't have like a solid solution. But our solution will be, my solution will be the day after or after it happens to evacuate really fast, to cancel all flights from the airport, and yeah.
And me too, just to evacuate the people for them to not get exposed to radiation.
I do think, and actually it's being planned, that containing the site where the nuclear explosion happened is a good way of avoiding more expansion.
How did we feel working like this? Well, we felt more connected and like it wasn't really fun, but it was interesting to see how we like videotaped us and all of that stuff. So yeah, we worked really good together.
It was really a challenge, but I think we successed and it was kind of difficult.
I think that working in teams can be fun, but we need to concentrate more because we need to plan things in advance.
Did we like it? Was it difficult?
Uh,
Yes, I think it was kind of difficult, and I like it. Yes, I learned something from this project.
I wouldn't say that I loved it, but it was like interesting. And was it difficult? Yes, it was difficult, especially because we left all the work to like 2 days or 3 days, and it was really difficult to finish.
As I said earlier, I did like it. It was very fun, but it was difficult because we didn't plan in advance with enough time, and we must do it the next time we make a project together.
What we like the most of working with our teammates in this firm, well, that we convivir, we bonded, and that we worked in this really good. Yeah.
I connected more with my peers, and it was a really good experience.
What I like the most is that my teammates and I have already worked before, but this as was a more challenging project. Taught us more about focusing on the objectives.
Thank you.
Tú empiezas.
¿Cómo?
Tú empiezas.
Come on.
Exponential growth is a mathematical change. Mejor lo escribo antes. Nuclear energy is considered clean energy because it doesn't
generate.
By then, to prevent the amount of radiation to get inside a house, they should block all windows and doors with iodine tablets, but this was not told by the government. They maintained it in a secret. After 30 hours, the first security measures were made. 1,000 buses came to evacuate everyone. In 30 hours, in 30 hours,
Now I'm going to show you a video about the explosion.
The heat waves released in explosions cause massive fires. Short-term sickness includes vomiting, diarrhea, intestinal malfunctions, leading to dehydration and malnutrition. Strontium and cesium emissions cause thyroid cancer. Strontium also causes bone cancer and damages in the bone marrow. Radioactive emissions also have consequences on the DNA that can be passed through generations, leading to malformation of newborns of the mothers that were exposed to radiation. The heat waves released in explosions cause massive fires. Short-term sickness includes vomiting, diarrhea, and intestinal malfunctions, leading to dehydration and malnutrition. Strontium and cesium emissions cause thyroid cancer. Strontium